Now I want to discuss with you what is the chain rule, what is the product rule and what is the quotient rule. First, what is the chain rule? The chain rule I will explain you with the help of one example. Suppose there is a function fx given by sine of x square. To find the differentiation of this, we know that the derivative of only sin x is what? Cos x. But here we want to find the derivative of sin x square. To obtain the derivative of sin x square, what we need to do, this x square will be assumed as a new variable. Suppose I am saying it is what? U. So the function becomes, suppose y, it is sine of u. If I ask you to differentiate both sides, with respect to x, so this y will be dy by dx and sin u will be cos u into du upon dx. On putting the value of u at both the places, I will get dy by dx is equals to cos of x square into derivative of x square. So the value of dy by dx become 2x because the derivative of x square is what? 2x into cos of x square. So solving a problem with a continuous process is the chain rule, which I explained you with the help of one example. This chain can be more longer, which I will explain you in the next example. Now I want to explain you that how chain rule is applicable in a longer chain. Suppose the problem is log of tan of root x. To solve this problem log of tan of root x, first we will assume this entire value as u. So the problem become log u and the value is suppose y. On differentiating both sides with respect to x, what will become this y? Dy by dx. And this log u become 1 upon u and derivative of u will be du upon dx. As usual approach, u is the cost of tan root x, which will be put at both the places. So the value of dy by dx become 1 upon tan root x. This is tan root x into what? D upon dx of what? U. U is what? Tan root x. Now the value of dy by dx is coming out 1 upon tan root x into derivative of, if this root x, a new function, is assumed as v, then we will say it is tan of v. So the value of dy by dx is coming 1 upon tan root x. Derivative of tan x is sec square x. So derivative of tan v will be sec square of v into dv upon dx. That's why dy by dx become 1 upon tan of root x. This become 1 upon tan root x as it is and into sec square. In place of v, we are bound to write root x into derivative of root x. The derivative of root x, we know that 1 upon 2 root x because it is x to the power half. So final answer of dy by dx is 1 upon tan of root x times of sec square of root x into 1 upon 2 root x. This is the answer by using the chain rule for the problem if y is equal to log of tan root x. Using chain rule, find the derivative of cos of sin x. to find the derivative of cos of sin x by the chain rule, suppose this is y. And we can say y is equals to cos of v if sin x is assumed as an angle v. On differentiating both sides with respect to what? X. So this will be dy by dx, and derivative of cos is minus sin v and dv upon dx. On substituting the value of v which we have assumed, dy by dx is equals to minus of sin. In place of v, we will write sin x. So this become minus sin of sin x into derivative of v means sin x. So final answer is coming by using chain rule. For the derivative of sin x, we say cos x, and this is negative as product into sin of sin x. So this is net derivative of the function cos of sin x using the concept of chain rule. So chain rule is nothing but it's a successive process of differentiating the things in the functions in their respective order.